Okay, today we're going to be talking about using shapes in the coordinate plane and how to prove them. So you're going to be given certain shapes and they're going to say, oh, this is a 2-unit by 6-unit rectangle. And you're going to have to put that in the coordinate plane. So let's title it coordinate plane first of all. Then you need to determine what's the best place to put this shape in order to put it in the coordinate plane. So if I have a 2-unit by 6-unit rectangle, one of the best places to put those objects are right at the origin because you're dealing with nice numbers that are zeros. So having it go like this, starting at 0, 0 and going to 2, 0, and then going up to 6 and 0, 6, that's a good place because you have a lot of zeros you're dealing with, and if you're going to be using that for the distance formula, it'll make it a lot easier. This way would work as well. It says one side is centered at the origin and the x coordinates are opposites. And so that gives you opposite numbers, which would also cancel out numbers and give you nice numbers when you're finding the distance formula. So you want to use that origin when placing objects in the coordinate plane. Let's see how that works. So a right triangle has legs of 5 units, of 5 units and 12 units. So that means you have one with a leg of 5 and a one of 12. So this person actually decided to place the end point of the hypotenuse in one of the legs at the origin. So you have 0, 0. And then they went out 12 because you know that one of the legs is 12. And then they went up 5 because it's 5 on this side. So you know that you can actually label it if you like, 12 here and 5 here. But we don't know our hypotenuse, and they're asking, how do we find that? So label the coordinates of the vertices and find the length of the hypotenuse. One way you can do that is using the distance formula. So if you want to find that hypotenuse, you're finding what's the distance from this point to this point. And because we put it at the origin, it's really nice because you're just putting in zeros. So you plug it into your distance formula, 12 minus 0 squared plus 5 minus 0 squared, and that gives you the square root of 169, and the square root of 169 is 13. So we know that hypotenuse is 13 units. So that's the point of putting it into the coordinate plane, that it helps you visualize when you're trying to find distances. Let's see another instance in which it comes in handy. So it says in the diagram, triangle MLO is congruent to triangle KLO. They want you to find the coordinates of point L. So if you know these are equal triangles, then that means if they're set right next to each other, this is going to be the midpoint, right? Because these are equal distances here. So you can use that midpoint to find the coordinates, the midpoint formula. So you have the point L, x and y. So you're going to do x1 plus x2 over 2 and comma y1 plus y2 over 2. And you just use your coordinates. So the coordinates they are using would be the m and the k because they're finding the midpoint between those two. So they plugged in 160 plus 0 divided by 2, which gives them 80. And then they plugged in 0 plus 160 divided by 2 gives them 80. So the coordinates of that midpoint are 80, 80. Now this next section on the right hand side is a little more difficult. This is when we're looking at proofs. Yay, we love proofs. All they're asking here though is to write a plan for the proof. So we don't necessarily have to write out 1, 2, 3, 4, and 5. So it says write a plan to prove that SO, the ray SO, so we have SO here, bisects angle PSR. So we have PSR. So that we're looking at that section right there where it's bisecting. So they gave us that the coordinates of the vertices of angle POS and angle ROS. So they gave us those coordinates. So if we have those coordinates of the vertices of POS, so right here, and ROS, the triangles, they give you all the points. How could we find out that SO bisects angle PSR? So the plan is, first, use the distance formula to find the side lengths of triangles POS and ROS. So they just want to know, find out the lengths of the sides, and if you find out all of those lengths, then you can use that side congruence postulate to show that those angles are congruent, or triangles are congruent. Finally, use the fact that corresponding parts of congruent triangles are congruent. So that means that angle PSO and angle RSO are congruent because the triangles are congruent. That implies that angle or ray SO bisects PSR. So bisects means this is equal to this, and that makes sense. If these are the same amount, they're equal, and it's going through right through the center. So that's just what you would do. That's your proof plan. Go ahead and write that proof plan. You don't need to worry about this down here. You can read it, but really what I want you to focus on is that. And that's it for tonight. Thank you.